In the previous class, I gave an overview of the straight line topic, and we now want to start to dig into some of the details of the things I talked about. So the gradient, the y-intercept, the equation of a straight line, and trying to pull all of that stuff together. So it does get a little technical, this topic, but it's a great topic to work because it merges both algebra and geometry, basically. So kind of algebraic geometry. So going between the algebra and the geometry is really the key to being successful in this topic, but it's not easy at first, so be patient with yourself as you work through this topic. So in this class in particular, we're going to look at the gradient, the steepness of straight lines and how we measure that steepness, and we'll talk about a few special cases and just try and get a feel for what the gradient is. The gradient's one of the components along with the y-intercept which define the equation of straight lines, and it's towards the equations of straight lines that we're really moving with these classes. So first of all, let's just get an idea of the orientation of sort of gradient. So I'm going to draw an xy axis here, and we're just going to think about what the gradient of certain types of straight lines comes out to be in general, and then we'll kind of flesh that out and then we'll look at some examples. So basically, if you've got a line, well, let's actually start with a horizontal line. If you've got a horizontal line, remembering that gradient is just a fancy mathy word for slope or steepness, then this line here obviously has got no steepness. It's flat, it's horizontal. So it makes sense that we assign a gradient of 0 to that line. So you don't see many questions with horizontal lines, but just know that horizontal lines have got a gradient of 0, and that's maybe your starting point for thinking about the gradient, the steepness of a line. We define a line which slopes up to the right, so going left to right up the way as you're moving along, so up the way. We define a line like that to have a positive gradient. So just remember that, there's nothing really magical about that, it's just up to the right, positive. If a line slopes down to the right, then we say that it's got a negative gradient. And then finally, the only other option is if you've got a vertical line, which again are really unusual. Most lines will have a positive or negative gradient. Horizontal lines pretty rare. Vertical lines even more rare, as we'll see why in a moment. But these guys don't have a gradient. So we say that the gradient for these guys is undefined. And in fact, these guys have also got a special different equation type to all other straight lines. These guys, the horizontal line, the positive gradient, the negative gradient, they've all got a particular equation type. This guy, the vertical line, is a bit of a freak. He's got his own little equation type and he doesn't have a gradient. It's really important to note though, undefined does not mean 0. A lot of students will say, okay, I've got a vertical line, that doesn't have a gradient, so the gradient's 0. That's not quite right, because 0 is, remember, a numerical value. It's just 0. So this is some number positive, this is some number negative, this is some number, but it's just a 0 number. This guy just doesn't exist, okay? So just not there at all. So different scenario. Okay, so let's start to think about how we actually measure the gradient. So we know the general overview, positive, negative, 0, undefined. How do we actually measure it? Well, we measure it by taking 2 points on a line. So let me actually just make a little space here. So we'll just take these off the end. So what we do is we take 2 points on a line. So let's say we've got a line going like this. And there's 2 ways you can do it. They're both kind of formulaic, but they essentially capture the same thing. So let's give this guy coordinates. So let's say that this point is 2 along and 3 up. And let's say that this guy is 6 along and 10 up. So obviously as points change, the orientation of the line changes. Like if this point here was at 6 along and 12 up, then it would be up like here somewhere, and the line would be steeper. The line would be going through that higher point. So there must be something about the points which tie in with the gradient of the line. And basically we just define it to be the ratio between the horizontal and the vertical change between the points. So what does that mean? Well, if you imagine almost constructing a little triangle here, and if we call this change in height between the 2 points, if we call that the vertical, which it kind of is, right? It's a vertical change, a vertical distance, and we call this horizontal difference, just call it the horizontal. Then we define the ratio between those two things to give you the gradient, which if you think about it, if you were walking like up a slope, if like for every step forward you take, you're kind of taking a certain height up, then that height up, depending on how high that is, would define the slope. If you're on level ground, for every step forward, if you don't go up at all, then you're on level ground, so your gradient of that line should be 0, which is a horizontal line. So that ratio is how we measure the gradient. And the way that we do it formulaically, well, first of all, we tend to use the letter m for gradient. So it's quite good to get into the habit of seeing m for gradient. And then using vertical and horizontal, we would just say it's the vertical over the horizontal. That is how we measure gradient. And in reality, these are going to be numbers, which we'll look at in a moment, and this will come out to be some numerical value. So in most questions though, you're not going to be given vertical and horizontal as direct numerical numbers because you're not going to have this sort of triangle. So there's not going to be like a number here and a number here. You're going to have to work those numbers out from the coordinates. And that kind of leads on to the second version of this equation. This is the correct version, but it doesn't quite give you the details. The details are that to get that vertical distance, you've got to take the difference between the y coordinates. This point's got a y coordinate of 3, so it's at a height of 3. This one's got a height of 10. The difference between those is 7. So it's that difference, and the same with the horizontal, that we use to actually define these numerically. So we call that y2 minus y1 over x2 minus x1. Now, so what do I mean by these? Well, what I mean is that if in general this point was x1, y1, and this point was x2, y2, just so that we can generalize it and get a formula, then all we're saying is you take the difference between your y's, which gives you the vertical, which is this number here. You take your difference between your x points, these two, put that down here, and then make that ratio, make that divide to get this vertical over horizontal. So for my example here, the y2 would be 10. The y1 is 3, so it's 10 minus 3, divided by x2, which is 6, minus x1, which is 2. So I get 10 minus 3 is 7, over 6 minus 2 is 4. So my gradient comes out to be 7 over 4. And if you need to process that on a calculator to get a decimal, then that's fine. Sometimes these will be whole numbers, sometimes they'll be decimals, sometimes fractions, it just depends. It could be all of those options. But notice that it came out to be a positive number, which is what we expected because the line was sloping up the way to the right. So which of these two formulas you use will depend how you've been taught this, if you've been taught it already in the school. In practice, this one is probably more useful, but this is essentially what you're doing. Remember, this is what you're doing. You're making the ratio between the vertical and the horizontal, and you're using this formula to remember how to do that. Okay, right, so taking the idea, let's go ahead and just work a few practice questions. Just going to make a little space here. So we've just been given these points. You don't necessarily need to plot the points, but sometimes it can be instructive just to draw a really quick diagram. Like, don't spend much time on this, but it just gives you an expectation if the line is sloping up or down or if it's horizontal. So if I plot the point 2, 5, so 2, 5, let's say that's there, and the point 4, 9, which should be up there, putting a line through those 2 points, it's clearly sloping up to the right, so we expect the gradient here to be positive. Just taking the numbers and plugging them into this formula. Sometimes it's useful to go ahead and identify them, so let's call that x1, y1, x2, y2. It's good practice to do that. I recommend that to most of my students. Just helps you keep track of the numbers. So the gradient will be y2 minus y1, so that's 9 minus 5, divided by x2 minus x1, that's 4 minus 2. 9 minus 5 is 4, 4 minus 2 is 2, 4 divided by 2 is 2. So that's come out to be positive 2, which ties in quite well with that gradient. So that's fine, that's all we basically do for that one. So we'll draw little sketches for all of these. Let's fire up one for this guy. So 3 along and 7 up, let's say that's like there. 10 along and 7 up, that's like there. So notice that the y coordinates here were the same. That means that the points are at the same height. So that means that this is going to be a horizontal line. We don't even really need to go through the formula because we should get a 0 when we put the numbers in, but let's just do it anyway for illustration. So x1, y1, basically you need 2 points on a line. This is your criteria. You always need 2 points on the line, or 2 points and then draw a line through them to make your straight line and then to get the gradient. If you don't have 2 points, then you're probably not going to be able to make the gradient. At least not until you get to more advanced questions where you've got slightly other methods to do that. So let's just check that this one comes out to be 0. So made a little deliberate mistake there. I'll just change that to y2. So obviously you spotted that, right? So y2 minus y1, that's 7 minus 7 over 10 minus 3. The numerator comes out to be 0. Denominator comes out to be 7, but it doesn't matter because 0 divided by anything is 0. So we did get the 0 that we expected from the diagram. Okay, cool. Right, so turning to the final example, so just firing up a quick sketch. I really always recommend these little sketches to my students. They literally just take a few seconds to do, and it gives you an expectation for what the numbers come out to be. Because the formulas here have got negatives in them, it's easy to miss negative numbers and to make mistakes with negative numbers. So I would say be ultra cautious when you've got negatives, and if you do make a mistake and you don't have a sketch, then you've got nothing to kind of bounce it off to check it. If, however, you've got a sketch to refer to, then you know that the answer is going to come out to be either positive, negative, or 0. Okay, so let's check out this one. So minus 3, 8, let's say minus 3, 8 is like there. Minus 3, 5 would be like there. So these guys have got the same x coordinate. So let's see what happens when we plug these ones in. We expect this to be undefined, but how does that actually come out in terms of the algebra? It was easy enough to see how, sorry, not the algebra, the numeracy. It's easy to see how we make a 0, but how do we make an undefined number? Well, let's check that out. So we'll set this up, x1, y1, x2, y2. Just running through the formula again. So it's y2, which is 5, minus y1, which is 8, over x2, which is minus 3. And then it's minus, because the formula is a minus, minus 3. So you've got to be careful with those double negatives. So top line becomes minus 3. The bottom line, though, is negative 3 plus 3, because you've got a double negative. So negative 3 plus 3 is 0. So over 0. So that's always going to be the case when you've got 2 points stacked above each other, because the bottom line is the difference between the x coordinates, but these guys have got the same x coordinate. So the difference between them is 0. But now we're trying to divide by 0, which is an undefined operation. So in other words, if you try to put that in your calculator, you're just going to get a big fat error message. So this is called undefined as a numerical operation. So that's why we say that the gradient of these vertical lines is undefined. Effectively, just because you're dividing by 0 in the equation to get the gradient. Okay, so that is how you find the gradient of a straight line. Essentially, you need 2 points on the line. If you're being asked to find the gradient and you don't have 2 points on the line, it's likely something's gone wrong in the question, or yeah, that should be your expectation to have 2 points. Once you've got your 2 points, you're just going to use one of these versions of the formula. They're essentially the same thing. This is probably the more practical version, where you're just identifying your x1, y1, x2, y2, plugging the numbers in, maybe drawing a quick sketch. Quite often these questions come with a sketch already. If they don't have a sketch, maybe plot the points, draw a quick line through them, just to get orientated so that you can expect a certain answer, and checking that the answer comes out to be tallied up with the graph itself. So not a particularly difficult technique, but it is one that takes a while to get used to, and especially around things like identifying the points, making sure you don't miss double negatives. So working a variety of question types until you're pretty much nailing these every time is definitely a good call. So make sure all of that stuff that I've said there makes sense, and then check out a few practice questions.